Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Hello everyone. In the previous video, we have seen that how Kubernetes really works under the hood. What are the Kubernetes component interact with each other, and then they are they are using underlying technology, which is Docker, which could be any runtime engine. By runtime engine, we mean that any technology that virtualize or Dockerize stuff, LXD, LSX, Containerd, I don't know, whatever it is. So now today we are going to look practically that how we can install actually Kubernetes. For that, we'll take the help of Oracle Box. Here we have created three different nodes to match our architecture because Kubernetes always work in the master client architecture. Master node essentially doing nothing. Doing nothing means that it's not allowed to have containers and pods. We have discussed what is the port. Why it is so? Because the master is something which is controlling everything, managing stuff, and making the resources available. But if you need that, you can also create that one. And next advanced concept is that we can also create multi-master architecture. So if something went wrong with the master node, what happened to the API server and controller and schedule in database, and to make this smooth running of all the cluster. Normally, you can create multi-master architecture where there is more than one master. Essentially, these all sources are also container, which means that this is uh, this is nothing but they are separate containers. They are also containers, and they also use the same principle. And you must install actually kubelet here, kubeproxy, and CRI Docker. Everything you also all the component you install here, you must also install on the kubemaster because kubemaster is also running on the containerized environment. It is nothing but it is also all these power sources are running on containers or the ports. Okay, well, fair enough. We go here. We run all three machines. You need more than 4 GBs memories because it is a little bit heavier. One. You can also use cloud, any kind of cloud, let's say like that, Google Cloud, or but unfortunately you cannot do it with free tier eligibility because you need to pay money for that, both on AWS and on GCP. Yeah, GCP is doing differently because it gives you money, direct money to spend. It's not giving you free tier eligibility like AWS with T2 micro or T1 micro. They're very small PC configuration or virtual machine configuration, but GCP is giving you direct $300 and you can do whatever you want to test the GCP, and there you can get 8 GB or more, and just for the trial purpose. And for this sake, we have Node 1. We need to install it, start it, and we need to start Node 2. And first thing first, that if you're using the corporate network, or you're using the university internet, or you're using the internet which is not at your home internet, or maybe for some reason, sometimes your internet is get blocked by the or some features of the virtualization of the internet is blocked. Um, if that happens, you can simply create a new network, right? You can just create new network here, file device internet network setting. And before you go there, you need to come here and you create a new internet Here I have created new network. You can see here, and I have configured the IP address to something. For the number 2, I have given some IP address. You can give whatever you want. And this is the mask. It's also mostly 2555 bits, and you create here, you enter yes, and it's going to create number 3, and it's automatically configure you something. And on the net tab, you can come here, right, and you can enable DHCP, and you can create your local network with some IP range with some bit masking. In the previous tutorial, we have discussed this in detail, that what does mean by that. Um, why this is important? This is, let me just remove this one. We don't need that one. And yeah, pretty much this is VirtualBox. And in the network setting of the each machine, you need to choose the network with network you have created here. In the advanced, you need to connect all the cables and hit OK. Why we need that? We need that because of we can arrange them some way. We can choose the second node, something like here, and we can use the master node, which is kind of here. It's already docked here. Okay. Now the problem with some computer is that when you run the virtual box, if you configure machine higher, it's not running smoothly because there are some throttle maybe due to NVIDIA and GPS driver, GPU driver, sorry, not GPS. And we need to wait until all the machines are ready. So this machine is ready, this machine is ready, and this machine is kind of not ready. I don't know. I need to power it off and power it again on. Because master node is always doing some problems. Okay. In meanwhile, that starts machine, virtual machine, I need to tell you that one problem is that Kubernetes using the underlying stuff. The underlying stuff, I mean that containerization technology. And for some reason, I don't know what is the reason, but for some reason, Kubernetes said that they won't be officially carrying on with the Docker as a Docker runtime or as a runtime engine or the containerization technology, they said. For that reason, the Docker is a kind of a loved one tool, highly and mostly used by the organization due to lots of feature it gives. And that's why they come up with the trick that they need to configure on top of the Docker something called Docker CRI. And Docker CRI pretend like that Docker is not installed, but Docker D is installed. So this is a small caution before installation. What we need to install, we have here each and everything ready to install. First, you need to prepare your master, right? I'm going to prepare my master. On the master, what I'm doing, I'm actually going to run some script. Great. And these scripts are essential for running your. I'm gonna give you the exact link of the GitHub as well. GitHub and this one. I don't know what was that. It was lab, I guess. Labs. Oops. Oops. I should go here. Labs. In the labs, we should have Kubernetes. In the Kubernetes, we should have how to install it, right? Install. We are using this version and this Ubuntu because on the machine we have Ubuntu. And that is actually, I'm going to give this in the tutorial link below. And first thing first, that you need to install this, what it does, just installing Docker with this script. The sh script is already written because either you go to, official website. On the official website, you run multiple commands one by one, blah, blah, blah. Other than that, it's the second option, which I get from here actually already available. I have to write this to show you that for this inside in the scripts, this is nothing but very quickly I went through. It is basically write this as install Ubuntu function, and in the end, it's called that function. It says that if it is already start Docker, it's stop everything and remove everything and clean everything, and then continue installing the Docker here. This is the just official steps if you go to the Docker homepage, right? And then it's automatic. These functions are written to automatically detect your operating system if it is CentOS, whatever. That's what it's doing. It's not doing any mystery or any stuff. Since we have installed everything on our machine, which means that in the previous tutorial for the Docker series, we have already installed everything, which essentially means that we don't might be need to install everything with respect to Docker on all these three machines. That requirement is fulfilled. We can check with maybe we can just check that Docker is installed or not. Let me just minimize this. Control Alt T, Docker V. Looks beautiful. Docker is installed. Docker V, Docker is installed. Beautiful. And where is my terminal? DOCKER Docker V. We have installed Docker version, which means that one of our requirement is filled. Now, second thing I told you that we need to do some trick actually, and this trick means that we need to install the CRI for some reason. And what it does, it's doing nothing, but it simply act like that you have installed Docker D shell rather than Docker. Docker D is another technology. It's not same Docker. It's another open source technology, and because for some reason Google stopped working with Docker or not working with Docker, but officially supporting the Docker, it doesn't support anymore. That's why we need to do this trick to just copy it here, and we need to paste it here. One important note I have written somewhere: before doing anything, if you're running virtual machine, and maybe on some machines, it it could waste a lot of your time figuring this out, because swap memory, if you're running swap memory, your Kubernetes tools like kubeCTL and admin and kube engine won't be running. And if your kube engine is not running, this means that your kubelet is not running. And if your kubelet is not running, you cannot install doing anything. So first thing first, you need to go to the every machine and you need to turn this off, the swap memory. Then you install Docker on each machine. Then you come on the master machine, because this instruction is for master. You copy this code here, you go to master, you minimize this, you just paste it here, boom. You supply the password, right? And now it's acting like whatever you call it. Then the second big thing is that there are a lot of small tools you need to run before make every cluster available, nodes ready, and communication ready. Main component we have seen here, but some other component. For that reason, Kubernetes always on their official documentation page ask you to install the tool, which is actually nothing but a software management like APT in the Linux or any uh, Conda in the Conda for the Python. This is just a package management tool, kubeadmin or kubeadm. And other than that, you need to install these two things separate. You copy the script again. The script is nothing but a compilation of the command in the bash, as I shown you in the case of Docker, for the sake of ease. And I can show you as well here. So it is just nothing but if I go here and if I go here and if I go here, no. If I come here and then if I enter this one, it is just a script. What this does that script. This script first detect your system, and it's just getting some key from the key rings, install it in your etc key list, adding a source list as a new package so that the Debian repository can be updated and then get update that to get this and install this stuff. This is just a simple stuff it does. Nothing to worry about. Great. So we are going to install this whole script again. And good thing good. I just minimize this. I come here, I paste that, I hit enter. Okay. I didn't paste it correctly, which means that you need to paste it from here, and you just hit. I'm going to give you this whole link in the end. And it's gonna take some while to make this stuff ready. If it wants to overwrite me this engine, the GCP keyrings, I say yes. And as you can see that all the required necessary items are installed on my master. Now, somehow you need to verify that everything is installed. Docker we have check CRI Docker D version. Great, it's there. Next thing is kubeadmin. kubeadm version output. Oops, output not white but short. Cool. Kubelet, an important thing to kubelet, important thing to run the boards, and then kubectl, kubectl, and then version CLINT. Cool. Everything is ready, which is good news. So, well, now, okay. Now the thing is that the other thing is that you need to initialize always your kubeadmin, but the thing is that you need to initialize it from different socket. Socket means that we want to bypass that restriction somehow, that it restrict Docker as a underlying containerization technology. For that purpose, we need to initialize with CRII. And if I hit enter, it's going to do some stuff, and then in the end, it should give me it could take 4 minutes. Meanwhile, let's discuss that what else we need to do here. Well, the second thing is that you go to your home directory and you just create a secret file with the .cube, because if the file has folder has directory has dot, it is hidden directory, and you copy your admin configuration file which we just have created to this home file. Okay, and then you change the ownership of your user and your group, both them, user and correspondent group, to this configuration file, because you own it, or that's why if you don't own it, it never runs. Then you install any network driver, as we have discussed here, that without kubeproxy and network interface, you cannot do a networking, which is the everything which is very necessary. For network, we need to install this Calico. Calico is well famous for the Kubernetes, but there are tons of different options you got. Calico is coming from this word where you have rugs, um, rough rug to knit it. In the in the older time, people used to create rugs out of it, and now Calico is also cat with with three patches, and this name is after that beautiful cutie cat. And what you do, you just install it from this Kubernetes apply F, and then you just apply this configuration from the YAML, and then it should work. Okay, something here happened here again. Okay, I think so. The swap memory is not persistent. We need the string again. Let me just go here and turn my swap memory off, sudo swap off everything. Sudo swap everything, and then try this once more. And might be we get some. Okay, cool. It's look like that it is giving us this join address. This is nothing but the IP address of this machine. And this is the token. And we need to add here CRI for again the strict for that thingy, Docker CRI. And we could join all the nodes we want. If your cluster is very big, you can also do this configuration with help of configuration management tool like Ansible. We have a complete tutorial on that. You can go to the playlist and watch those tutorial as well. But right now, this is not a topic. So since okay, so that's that. Then I can say that kubeget nodes to check if everything is working. Kubeget. Uh, I don't know. My spelling's really. What's the spelling of cube again? C with C, right? KubeCTL. KubeCTL. Get nodes. Okay. Why that happened? Because earlier we have configured everything on these machines, and now we need to again write this thingy on each of the machine, which we are going to do in this fashion that I'm going to do this, and then we need to attach this socket, copy, so that I don't have to first, ay, ay, ay. Okay, keep text only, and then this is join. And if I hit this, maybe, and then it joins. Okay. Okay, I'm doing something wrong here because let me just figure out that what I'm doing wrong to uh, this is the complete okay. So let me just write the command again here. This is the command here, and then I can add socket here, and then I can maybe copy this. It might be that works because I was missing okay, which means that you need to add sudo as well. Hmm. Here again, I need to turn off the swaps. That is setting. Sudo swap of A, and that, and then that. This has already, okay. First, I need to, okay. Now the thing is that I have already registered these nodes on another cluster while I was testing. And now because these are already occupied with something else, that's why the kube configuration file already exists. I need to first deregister them. Let me just deregister them first. Okay, let's just first create this whole process maybe. Okay, now you have this configuration file copied. You copy this configuration file here and copy it here and change the ownership. That's also a necessary step. Then you have to also apply this Calico network drivers. Okay, and then okay, nodes are not going to work because these nodes are already joined somewhere. Okay, and well, the great thing is that now it's getting certificates like old certificates, but in real time you have to the process is really same. But right now, because it's a configuration file already exists, and it says that file already exists, and somehow because it is in the local area network and nothing has been changed, that's why it was able to communicate with each other. And it says that kubectl nodes are here now available because now we install the Calico driver, and we also copied everything from the home directory to this content of the kube config. This is the hidden file, and your master is still not ready. After some time, it should be ready. You keep checking. Maybe after some time, it's ready, ready, ready. Okay. Mm-hmm. Okay, on the machines, two nodes, you need to install that. And you need to do the same again for this Docker thingy. And then you need to similarly install this. You need to do this, and you simply then join this as we have joined here, and your process should be okay. So might be this kubectl is not running. Let me. Okay, I have turned off here this swap memory again, and I hit here enter, and everything is ready. Because that was master was ready, everything was ready. I checked the kubelet journal entries in the control panel, and it was taking a little bit longer as expected. And there could be two options. There's network problem. So let me just tell you how I saw it. The status was not ready on the Nitro. I see that Nitro is either a master or node. Nitro is here, which is actually node, and it is not working. Then I have to check this general control of the kubelet, because kubelet is ultimately stuff that is creating the infrastructure. And then it told that housekeeping took too long, which means that it's too, getting getting too long to communicate with this node structure, which means that this is working fine, but this is not working. One thing we could see that IPA. Well, now the IP address of this is in the ESP3, and IP address is 10.2.15, and I can ping this here. And when I ping 10.0.2.15, and it's working perfectly fine, which means that network is okay, then the always suspect is the swap memory. I make this swap memory off again. It's trying to check, and everything is ready. Now you can see that our infrastructure is completely ready, which means that we have all the nodes here. All the nodes are working perfectly fine here. We can always create a port, and now we can write a YAML file. With YAML file, we grab some custom images, and with custom images, we create an infrastructure, and this infrastructure is distributed over these two nodes, automatically managed, created. That's how actually we do this clustering installation part. Our installation is ready. Our communication with node is ready. Everything is perfectly fine. That's how you figure it out. I'm going to give you the description of this GitHub link where you can get all the installation code. And beautiful. That's how you configure successfully a cluster of your Kubernetes. And now the next step, You get the file of the Kubernetes, some image file, some instruction to get, you have some application, let's say like that. You have code. Code is written in Python. You need some dependencies. You pack up everything in the Docker file, similar to Docker file in the YAML. You create your custom image, whatever you want in the Docker or whatever containerization technology. And then you really tell this system that, well, this is what I'm going to do, and that this is what I want to do. And then it's automatically create the infrastructure for you, create a container of your code, and your application is perfectly fine running. And the beauty of this Kubernetes is that regardless this container is killed as many as time, crashes, whatever happens, the pod is going to create a new container with the fraction of the seconds. And this infrastructure is used by Google, and that's why you see there's a lot of less outage in the Google, because Google is using this Kubernetes and they have built this and they have worked 15 years on that, and then they made it open source for the industry. In the next coming up tutorials, we are going to see that how you practically deploy your application on that. And after deploying your application, how you can understand the networking, that how the port actually forwarded to each of the cluster nodes, and how overall networking concept, which is essentially from the gateway to the subnetwork mask, virtual networking, communication across the nodes, communication within the nodes. These concepts we are going to discuss with in detail and with demo. Thank you very much for watching. Bye for now. Stay tuned. Watch other playlists. This is whole complete series. And if you think that it helps you, please hit the like button and subscribe button. Thanks a lot. Bye.